Hi, good morning, everyone. Welcome to the Maputo Mobility Prediction Challenge. My name is Amy. I'm a data scientist at Zindi, and I'm so glad to have you here. If you would like to introduce yourself, please can you post a comment on YouTube? I'll be able to see your comments. This also goes if you have any questions. Please can you put your questions in the YouTube chat, and I will answer them as we go along. I've prepared some slides for you, so we're going to go through the slides. Let's just go through it and we can see how it goes. So the agenda for today, this is my welcome. We are then going to have an introduction and a welcome from Mohammed Adam, who's a general manager at Yango, Mozambique. Some of you have been on Zindi before and some of you are new to Zindi. So I'll do an introduction to Zindi, where to even find the competition, how to sign up, what are the rules, what does the challenge look like. I will then also introduce the machine learning AI hackathon. And I've also got a notebook, which is a piece of code that I'll run through and show you how to write code and how to make a submission to Zindi. In exactly 1 hour, so at 10 o'clock, the hackathon will launch, and this means you'll be able to download the data and start making submissions. You then have 8 hours until 6 p.m. to make submissions. You can make multiple submissions, so don't wait until 6 p.m. to make your submission. Try and make one every hour, maybe even 5 an hour. And then I'll see you all again at 6:15 this evening, where we will announce the winners and to see who wins $1,000, which is an amazing prize, which has been powered by Yango. Mohammed, I'm going to hand over to you now. So glad to have you with us.
Thank you, Amy. It is a pleasure. I'm going to switch to Portuguese. I believe most of the participants or all the participants speak Portuguese. So, bom dia a todos os participantes, representantes da Zindi, representantes das universidades e instituições que apoiam este evento. Em nome da Yango, é com grande satisfação que apoiamos este hackathon em Moçambique, focado na mobilidade urbana. Como é de conhecimento de todos, a mobilidade urbana continua a ser um desafio em uma grande parte das cidades africanas. As cidades em Moçambique não estão fora deste desafio, continuam a ter estas dificuldades. A Yango está presente na cidade de Maputo e na cidade de Matola. O nosso serviço, no fundo, é uma forma de ajudar os cidadãos da cidade de Maputo em movimentar-se de um ponto A para um ponto B de uma forma acessível, confortável e seguro. Acredito que muitos dos participantes que estejam cá já conhecem a Yango. Para os que ainda não conhecem, a Yango é uma empresa de tecnologia que está presente em mais de 30 países em África, na América Latina, na Ásia, no Médio Oriente e também em alguns países europeus. Nós, como empresa de tecnologia, valorizamos profundamente a inovação. Em todos os países que atuamos, investimos no capital humano e nos esforçamos para contribuir o máximo possível para as comunidades locais. Este hackathon reflete o nosso compromisso em Moçambique, apoiando o desenvolvimento do capital humano moçambicano, especialmente no crescimento da área de ciência de dados e também de inteligência artificial. Esta iniciativa vai naturalmente contribuir para estudos de como melhorar a mobilidade urbana em Moçambique. Portanto, gostaria de agradecer a todos os participantes por se juntarem a esta iniciativa, de modo a ajudar a melhorar a mobilidade urbana em Moçambique. Não vou estender mais. Acredito que os participantes estejam ansiosos para começar. Nós também estamos muito ansiosos para ver os resultados deste exercício, dos modelos que os participantes vão construir. Portanto, desejamos muito boa sorte a todos os participantes. Agradecemos a Zindi por nos convidar a colaborar neste projeto maravilhoso e às universidades e instituições que disponibilizaram os vossos laboratórios para acomodar os participantes durante o dia de hoje. Que o Hackathon seja um sucesso. Estamos ansiosos para ver os resultados e muito boa sorte a todos. Obrigado. Thank you, Andy. Amy.
Thank you so much, Mohammed. I think obrigado is the only word I know in Portuguese. I had the privilege of visiting Mozambique when I was 16. So great to get to work with Mozambican data again. So onward with our agenda, an introduction to Zindi and an introduction to the competition. Zindi is set up to do machine learning. It's a specific type of machine learning called supervised learning. I want to tell you a bit about my journey into machine learning. I started off as an intern. I was very excited. I'm going to move into AI and machine learning. And I got my internship and I had no idea what was going on. This is to reassure you that I started from not knowing anything. I didn't even know what to Google. This is to reassure you, we started somewhere, I started somewhere, and now I'm an official data scientist, and I can say with confidence that I know what I'm doing. So if you are the person that I started out as, which has no idea what to even Google, I'm so glad you are here. If you are someone who is at my level or even better, and there are so many amazing people on Zindi, I'm so glad that you are here. So this is the Maputo Mobility Prediction Hackathon powered by Yango. Just to reiterate, the competition starts at 10 o'clock today and finishes at 6 p.m. on Saturday. And the objective is to determine the average traffic speed at rush hour 6 a.m. and rush hour 6 p.m. Every day of the week for a week. You can work as an individual. However, I personally prefer working in a team, and you can work in a team of up to 4 people. I find working in a team is a great way to bounce ideas off each other and ask for help. This competition is only open to Mozambique participants, and please make sure that your country is listed as Mozambican. If you win the competition, you will be required to submit proof that you are Mozambican and that you reside in Mozambique. Prizes, as I mentioned, there's $1,000 up for prizes. First place is $500, which I just think is amazing. Second place, $300, and third place, $200. Again, powered by Yango. Yango, thank you so much. You will need proof to show that you are Mozambican to receive your prizes. The competition rules. I know we're just talking text and there's slides in front of you, but I will get to sharing the competition page with you, and you will be able to see the competition and what I'm going through. So as I said, you can participate individually or as a team. I'll show you how to create a team on Zindi. You may only use the data sets provided on the competition page. Please don't try and find some funky, cool data sets on the internet. Everything you need is on Zindi. If you are in the first, second, and third place at the end of the competition, so at 7 p.m., you will need to submit your code for review. We will let you know if you have won the competition at 6:15, and by 7 o'clock you need to have submitted your code to us. So please do join at 6:15, 6:15, to find out if you've won so you can submit your code. we need to verify that your code does what it does. If you're working in a team, of course, please do share code with your team members, share ideas, share motivation. However, if you are working individually, please don't share anything, and please do not share information across teams. That is considered cheating. If you would like to share code or insight or motivation, please do post on the discussion board and make it publicly available. This is a bit of a weird rule, but for you advanced pro data scientists, please only use publicly available and open source packages. If that doesn't make sense to you, you don't need it. And then again, only Mozambicans are participating in this competition. You can see full rules on Zindi, and I'll show you where to see these rules. I've whizzed through this really quickly, and I'm now going to dig into what the data is. This data is powered by Yango again, and we are so amazed that we get to see this data. If you have any questions, pop them in the chat. This video is being recorded and you can keep coming back to it. In the code I'll be going through, you'll be able to see this data and all the graphs, and it will make a lot more sense. So Yango's drivers drive around Mozambique, and the data they have is they've managed to take Mozambique, Maputo, and cut the roads up into road segments. These segments differ in length. Sometimes they're 10 meters, sometimes they're 100 meters, and each road segment is referred to as a persistent ID. You can see in that, I want to touch my computer screen over there to show you. You can see that blue line is a segment ID or a persistent ID. You then have 7 days of the week. They're not named Monday, Tuesday, Wednesday. They're named a bit different. So we have our first weekday, which is Monday, second weekday, which is Tuesday, all the way down to first holiday, which is Saturday, and other holiday, which is Sunday. A bit confusing, but this information will be on the competition page, and this video will be there, so you don't have to remember it all. What you are trying to predict, as mentioned, is the rush hour of 6 a.m. and the rush hour of 6 p.m. So how fast are cars moving? What is the speed, the average speed of cars on each of these road segments for the whole of 6 a.m. and the whole of 6 p.m. I helped in preparing this data, and my mind was blown. So if this is confusing to you, don't worry. You'll get it. So let's just talk about our unique IDs. So we've got 2,819 persistent IDs or road segments. We've got 7 days of the week, and we have 2 prediction times. So that's 6 a.m. and 6 p.m., which means we've got a total of 36,900 rows of data. What an amazing size data set that is. We love working with data in the thousands when doing machine learning. To identify each unique row of data, we've structured the ID to be that persistent ID, which is a very long number. So this is 1 bazillion, 1 million and something, crossed by first holiday, crossed by the time period. So that's road segment 1 bazillion, Monday morning rush hour. Can you predict what that rush hour for that road segment is? We've then taken the 36 or 37,000 rows of data, and we split it into a train and test. For you advanced data scientists, you understand what a train and test is. I don't need to explain that to you. If you are new to data science, I'm going to show you that I've got my ChatGPT open, and I'm going to show you how to use ChatGPT for data science. Generative AI is where it's going, so just ask it all your questions. So back to that train and test, we've split half of the country, half of the city, Maputo, to be train, and then the other half is your test. So there's no roads that cross over each other. So for an example, I don't know if I'm going to say these words right. Ponta, Maputo, Katambe is in the train set, and then Rua do Jardim is in the test, and that's for example. So we're not crossing over any roads. One road's in the test, one road's in train. Okay, so now we've described what the roads look like and where they are, but the next most important part is the time aspect. We've got average speed data or speed data all the way through for 24 hours of the day. However, Yango has split the data into 15-minute segments. So you'll see attached to each feature, you'll have something such as 00_0, and then 00_1, 00_2, 00_3. And that just means midnight, the first quarter. So from midnight to quarter past midnight. 001 is quarter past midnight to half past midnight. 002 is half past midnight to quarter to 1 a.m. and so forth. I'm looking in that top line of the over there. If we go all the way to the end, we've got the indication 01_3. That is the fourth quarter of 1 a.m. So that's 1 a.m., 1:45 a.m. to 2 a.m. So if you see any feature that has 013, you know you're looking at 1:45 to 2 a.m. in the morning. We're dealing with two main features. We're dealing with count norm. So this is the normalized number of trips. You can think about this as just the number of cars that traveled in that section. So from midnight, in the first 15 minutes from midnight to quarter past midnight, 0.81 cars traveled that road segment. If we go into the middle, at midnight 45 minutes past midnight to 1 a.m., there were no cars traveling. And then finally, all the way at the end, in the third segment, so that's 1:30 a.m. to 1:45 a.m., you can consider that as 0.36 cars traveled that specific section. Reassuring you, it took me a while to understand this. So if you're feeling overwhelmed or concerned, that means you're normal. Next, just as we have the count norm for every 15 minutes, we now have the average speed for every 15 minutes. So we've got the average speed of those 0.81 cars was going at 16.711 meters per second. Then the next 15 minutes, those 0.034 cars were traveling at 16.55 meters per second. So marginally slower than the first 15 minutes. I haven't seen any questions coming in yet, but please do post them. Okay, so now we have a kind of idea of what's happening. We've got our data in rows every 15 minutes. But what are we predicting? We're predicting a rush hour. So for the rush hour, 6 a.m. and 6 p.m., so that's 0600 hours and 1800 hours, you're not predicting the singular every 15 minutes, you're predicting a whole hour. So that's one thing just to like figure out in your brain. And then at Zindi, we've gone and done something else just to make it that much more tricky. We have removed the first half an hour before rush hour and the half an hour after rush hour. So for your morning rush hour, you've got data every 15 minutes from midnight all the way up until 5:30. But then you're stopped. You don't have data from 5:30 to 6 a.m. And you need to predict the average speed between 6 a.m. and 7 a.m., which is just one number. Then, not too important, we've gone and changed. We've removed the data from 7 a.m. to 7:30, just to scrub that away. And you've got data from 7:30 to the rest of midnight. For the evening rush hour, you have data from 7:30 a.m. all the way up until 5:30 p.m., 17:30 p.m. You then miss two 15-minute segments or half an hour, and you now need to predict the 6 p.m. Average speed. I keep using... So now I'm going to be talking to the advanced data scientists who think they're pros. You can see that we've got time data. So I'm hoping you're starting to think of a term forecasting. You can see that there's temporal, you've got time steps. Maybe forecasting is something you want to look at. You don't have to. If you have no idea what forecasting is, don't worry. We have set this up so that it's prediction. But you can still play around with forecasting if that's something that you are confident in. In the next little bit, I am going to walk through Zindi. I'm going to walk through this data again. I'm going to give you a bit of time to take a deep breath before we start going on to the next thing. Any questions? Again, ask on the YouTube chat. I'm going to be at my computer the whole day, so if you have any questions, you can ask questions on the discussion board, which I will show you. And then we'd love it if you could tag us on Twitter at Zindi Africa, and you can also tag Yango Education. I'm getting those hashtags right now, so you can tag us. We would love to see your photos. We'd love to see you hacking. We'd love to see you taking a break, because taking a break is important. So I'm going to join the competition, make a team, and get the data and get hacking. Please can you give me a minute while I quickly change screens to get ready to show you what's happening. I'm going to remove the screen. Brilliant. You can now see my Zindi screen. When you sign into Zindi, you'll come up to this page. You're going to look at the top right button over here, and there's going to be a sign in button. I'm already signed in, so there's nothing I need to do. However, the first step, I'm going to go and edit my profile. I'm going to make sure everything's filled in. Then I'm going to go to my country, and I'm going to make sure it says Mozambique. You can start typing that out, and you can click save. This hackathon is only for Mozambique users, so you have to tell us that you're Mozambican. Click save, I'm also going to go to my career page. This is a great way to tell us about yourself, let us know if you have any education or where you're working. I set up a hackathon for Zambia, so the University of Lusaka, so that's over there. If you'd like to add your other university, you can add it over here and remember to click save. Oh, there's an error because I haven't filled anything out, so I'm going to close it. There's nothing to save as I've changed nothing. I'm going to scroll up to the top, go to my profile, and I'm going to make sure that my university is correct. So I'm going to put Rhodes University and click save. This means my profile is up to date. Before I go further, I see that we have a question. So Mohammed, I'm going to ask a favor. I'm so glad that you've asked the question in Portuguese. But Mohammed, I'm going to add you to the screen again and ask if you could please translate that question for me.
Boa tarde. Quais as universidades que disponibilizaram os laboratórios? They are asking which universities made available the laboratory, the tech laboratories. I believe in Maputo was UM. Meu caro, em Maputo, penso que a Universidade UM disponibilizou o laboratório de informática para os estudantes da UM.
Oh, brilliant. Mohammed, I'm so glad that you're here to answer that question. Great. I'm going to remove you off the screen again and we can continue going. So now that we've updated our profile, let's go and find the Maputo Hackathon. So I'm going to click on compete. This is a hackathon. If you're interested in winning some more money, we've got some other competitions open, but that's not for today. Today is your Maputo Hackathon. You're going to click Hackathon, and you're going to find Maputo. Competition starts in 32 minutes, so you only have to listen to me for another 32 minutes. You can learn more about Yango. You can read to confirm what the competition is. Here is that live stream that you're watching right now, which means that you can come back here throughout the day to see and to double check and to make sure that you've understood everything correctly. At 6:15 p.m., please click on the second link to find out who the winners are. This will just be a short 10-minute live stream to find out who the winners are. The evaluation. When we score a machine learning or an AI solution, sometimes using accuracy is not the best method. Sometimes we need to choose a more appropriate way. I know when we do university tests, we just score, you got 79 out of 100, which means 79%. This competition, we're using the root mean squared error. You can click on this link to see more, but you can think of it as a standard deviation, and you're trying to minimize your standard deviation. So you've got your bell curve, and you're trying to make your bell curve as small as possible, which means most of your values fit within that. This is what I showed you in a previous slide. So for road segment 54 bazillion, the second weekday, which is Tuesday, what is the evening rush hour average speed? So what is the 6 p.m. rush hour? Prizes, as mentioned, $1,000 in total, so $500 for the first place, $300 for the second place, and $200 for the third place. There are also 500 Zindi points available, so you can read more about points here. We've gone through the timeline when we started this, but it is over here if you need help. If after this video you're still confused or you still need help, which is totally understandable, you can come and watch these videos. They're approximately 1 minute each. How to enroll in your first competition and make a submission, how to create a team on Zindi, and how to update your profile. So how to update your profile is to add your university, add your workplace if you're working, and add your country. Next, I personally work in Python. You can work in R if you feel comfortable working in R. Google has created an amazing product called Colab. So this is Google Colab, and I'll be showing you how to run the solution in Google Colab. These are 2 videos that show you how to use Colab. They're about 3 minutes each. It's just I think it's an amazing way to write Python code. As mentioned, here are the long rules for you to go through if needed. You can make 100 submissions today. So when you come to don't wait until 6 p.m. tonight to make a submission. Make submissions throughout the day, trying to see how far you get and if you can improve your score. I'm scrolling all the way to the top and I'm going to the data section. We've now got 28 minutes to go. I hope everyone's getting excited. We've got some more information about the data. And in 23 minutes, the data files will be available for download. So at 10 o'clock, please just refresh your screen and the data will be available here. Discussions. I've introduced myself over here. Please introduce yourself as well. I'd love to know what you're studying, where you're studying, if you're interested in teaming up. And then we have our leaderboard. If you make a submission, you will appear on the leaderboard. And the idea is to try and beat everyone on the leaderboard, which is quite fun. In 27 minutes, a button will appear over here that's called Submit. And you will submit your predictions. This is, I think everything I'm saying today is very important. But what you submit is you only submit a CSV file or an Excel file. Please don't submit your code. We only want your code if you're the first, second, or third person to confirm that you've won. Your code belongs to you. We just want your predictions to put you on the leaderboard. And if you're in the first, second, or third place, we will then get your information. Right. Team. There is a video that shows you how to form a team, but over here you can create a team. Please ensure that you create a team by 5 o'clock today. You can't create a team after 5 p.m. This is something important to note. Okay, wow, we've done a lot, but as promised, we've still got some code to go through. So if everyone just wants to take a deep breath, we've got this. I'm going to take some water. As promised, here's my ChatGPT. Okay, the Yango starter notebook for Mozambique. Yikes! Look at all that code. That's a bit scary, but I promise you it's not. This is Google Colab. I'm going to show you how to open up a Google Colab. So all you type in is Google Colab on Google. You click the first link. You're going to click New Notebook. This is exactly how opening a Google document or a Google Sheet would work, except this is Google Colab. So now we've got an empty notebook. If you'd like to start from scratch, you do not have to use the starter notebook. If you are confident, you can go off by yourself. We're now going to click File, Upload a Notebook. I'm going to Browse. And here we have Mozambique. I've already downloaded the data and downloaded the notebook. But when you come to the data page in 24 minutes, you'll be able to click Download and you'll find this notebook. Just going to give it a moment to upload. When I first started using Colab, I got a bit nervous, especially about the time it takes to do things. I'm so used to things being instant. So please give Colab about a minute to do each item. As mentioned, there is a video on the competition page that shows you how to do this. So while it's busy uploading, I'm going to go to the starter notebook that I've already uploaded. When it uploads, it will upload like this. There will be a button in the top right section that's called Connect. You'll click Connect. You'll wait approximately 1 minute 30 seconds. You'll then come to this side of the screen and you'll click the folder. You'll then click the Upload button. And you're going to upload all these files that you have downloaded from the data section. I've already uploaded them. Please give another 2 minutes for all the files to upload. Then I'm wondering if I should tell you this or not. You can close this because you can open it up at every time. But if you open it, you get to see your screen a bit better. If you want to be the first person on the leaderboard, all you need to do is you need to click Run All. And this code will just run. It will give you a submission file. You can run to Zindi and you can upload it. However, I don't recommend doing that because that means you haven't gone through the code and you haven't understood it. I'm going to go through this code. There's parts I'm going to go over quickly, parts I'm going to go over slowly. We need to install some relevant libraries, such as this GeoPandas folium. If you want to run items one by one, you just can click on the play button over there or the run button, and it'll run. Over here, we are importing the libraries we need. Pandas is a great library for viewing data frames or Excel files. NumPy, we've got some geometry files, as that will help us visualize maps of Maputo. Over here, we've got our sklearn metrics and what to do. And this is a great place to use ChatGPT. So what you can do is you can copy paste a line. I'm just going to go Control-C. I'm going to go into ChatGPT and I'm going to ask, what does this line of code do? And it gives you a wonderful explanation. You don't need to be a data science expert. You just need to be a ChatGPT expert. You can even go further. What is a random forest regressor? It explains ensemble learning, decision trees, randomization. Please don't be overwhelmed. ChatGPT is your best friend. You can see all the questions I've asked ChatGPT and that I'll ask regularly. One of the most important things in an AI or machine learning solution is to set the seed. This just means that every time you run the code, you can get the same results. We have a question from Dario. Can you use any other platform, or do you have to use Google Colab? You do not have to use Colab. If you have got Spider, Jupyter, Anaconda, R, I've even seen some people use Visual Code. You can use Visual Code to write your code to run this notebook. I personally use Colab, but you do not have to use Colab. You also do not have to use the starter notebook. If you are confident to use something else, go for it, and I encourage you to explore that. Okay, loading the data. We need to get the data into our environment, into the code. So here we have our train file, which is pulling just this train. We have our sample submission, which is pulling this sample submission over here. We have got our train over here. Okay, our train. Yeah, this is what I'll say. Here's your persistent ID. Here's your day of the week. I think LBO weekday is Thursday. So for this persistent ID on Thursday for 6 a.m., the average speed for that section of road was 5.11 meters per second. Again, as I was mentioning, we've got these values. So what is the speed average at 011? So what is the speed average at 1 a.m. from 1:15 to 1:30 for that road segment? It's 12.77. And how many cars were traveling at 1,500 hours at the 0 mark? So between 3 p.m. to 3:15, there were no cars traveling for that specific road segment. I'm going to scroll all the way to the end one more time. You can see that there is a column called target. If we view our test head, there will be the persistent IDs will be completely different between train and test, because as I mentioned, some roads are only in train and some roads are only in test, which means some persistent IDs are only in train and some persistent IDs are only in test. If I scroll all the way to the end, you'll see we are missing that last column, the target column. We've got all the same columns except for this last column. And that's what you are predicting. I'm going to scroll all the way to the left. I'm someone who gets car sick and I hate it when people do this. So I hope you aren't hating me for scrolling left and right. You can see that we have created a sample submission. And this is what when you submit something to Zindi, it needs to take this form. So every row in the test set, we can see 16 second weekday evening rush hour. We've got 16 second weekday evening rush hour. And here we have that target column. So you don't need to submit the whole of test. You just need to submit this 2-column file that has the same IDs as test, as well as your predictions for the evening rush hour and the morning rush hour. Now, this is another great way to use ChatGPT. I'm going to create a new code cell, and by mistake, I'm going to spell this the incorrect way, and I'm going to run it. And oh my gosh, I get an error, and it's red, and I don't know what to do, and I'm freaking out. What I can do is I can either click Search Stack Overflow, and Stack Overflow gives a great way. It tells you what to fix. Otherwise, I can copy paste this into ChatGPT. How do I fix this error? It looks like there's a typo in your code. The name's meant to be head, not head. Huh, thanks, ChatGPT. I can come back and run it. So if you're stuck, there's two ways to get that assistance, is to either click on the search Stack Overflow or to put it straight into ChatGPT. There's another data frame that I haven't mentioned before, and that's called the graph. It's a strange terminology, but if you are a math major, you might be able to understand it a bit better. If you are a maths major and have no idea what's going on, it doesn't matter. This gives you information about each persistent ID. So here we have the persistent ID. For the persistent ID 53, this road segment is 218 meters long. It's not a toll road. It's not restricted for trucks, so trucks, normal cars can go on there. It's not residential. It is paved, which means I assume it has tarred roads on. And then it has this geometry. If you put one row of this geometry into Google Maps, you'll be able to zoom in directly onto what this road segment is. Are there traffic lights? Is there a toll post? What is the name of the road? Oh, this road doesn't have a name. Oops. Some roads do have names. So this just tells us a bit about the road we're looking at. You do not need to use it, but it is interesting information if you are interested. As I was mentioning, the train shape and the test shape. Train shape, we've got 165 columns. For test, we've got 164 columns. That difference is, remember, test doesn't have that target column. We're looking at some statistical summaries. So inside the train, we've got 26,000 rows. Our maximum, if we scroll all the way to the side, our maximum speed is 45. So during one rush hour on one road segment, someone was going at 45 meters per second, which I think is a bit reckless, but yeah. Number of days, we've got 7 unique days, 2 unique prediction types, which is that morning and evening rush hour. Our target variable distribution. It looks like most cars during rush hour travel at approximately 9 meters per second. That's just something interesting to note. Maybe when you get your predictions, you can see, does it follow the same curve? Should it follow the same curve? A question to ask yourself, a question to ask ChatGPT. And now we have our outliers. Hopefully we've all seen a box and whisker plot before. Here's our box and whisker, and here are a couple of outliers. There's a handful of things you can do with outliers. I've mentioned them over here. You can either drop them, or you can replace this value with the mean or the median. There's different techniques. ChatGPT, your teammate might know. This is why I encourage working in teams. And this is my favorite part of the notebook, the road visualizations. And this is where we use the graph. In this notebook, we only use the graph for visualizations. You do not have to use the graph if you want to use graph for predictions. I'd love to see what that looks like, as I've not had a chance to explore it yet. So the road visualization. There's Maputo! How cool is that? So these are all the road segments that are in Maputo that Yango has data on. So we can scroll right in, and you can see that there's data for cars going that way and cars going this way. We can see like bus stops, shopping centers. This is an amazing visualization and an amazing way just to check to see. This competition is to determine the average speed. However, once the competition's over, it doesn't mean this data stops being useful. You can go and find where it's close to your home. I don't know, maybe someone lives nearby over here, and you want to see how long it takes you to get from this side to this side because you're going to be late for an exam. This is a great way to further extend the use of data, make it personal. Over here, this code shows you how to zoom into one section of road. So this is us just zooming into this section of road. And now we're going to look at some statistics about this persistent ID. A lot of code. If you don't understand what this code does, this code thankfully is just plotting. Plot without an O, subplot. Again, copy pasted into ChatGPT. What does this code do? And here we have some information about the morning rush hour for this specific road plot, for this specific persistent ID. So it looks like in the morning, cars normally travel at around 7 meters per second. Although at 2 a.m., 2:30, between 2:30 and 2:45, someone was speeding at 10 meters per second. It looks like there were almost no cars at 2:45 a.m. And it looks like cars are speeding up around the morning rush hour. That's interesting. In the afternoon, so from 7 o'clock, you can see that the cars have slowed right down. No one is topping 9 meters per second. They're all stuck around 5.5, 6.5. Although strangely enough, or not strangely enough, at 4 p.m., the traffic was almost standstill at 3.5 meters per second. I can walk my dog faster than that. There's information on how to determine missing values. What is the best way to do missing values? You can drop them. You can fill them in. Correlations. The speed just before the evening hour is highly correlated with the target. So maybe that's something to look into. If something's highly correlated, I would look into it. You can even plot the correlations. I want you to look at the right over here. I have spent 80% of this notebook looking into data, exploring the data. What does the data look like? What should I be expecting? What are the correlations? What does the data look like? How can I extend the use of the data? The last 20%, 15% of the data is the modeling. And I want you to keep this in mind for all machine learning, all AI solutions. The most important part is understanding the data. The modeling, people make it sound that the modeling's the hardest, but it isn't that bad. Over here we have our modeling. For the train, the way we do machine learning is we take the train and we train on it, we practice and we build our model. So over here, we're taking our train. This is the same code you'll use, so no matter what you do, you're going to drop the independent variables, such as the ID, persistent ID, the day, the prediction type, and the target. And you're going to set your Y value as the target. Oopsie. You're then going to split your data further into a train and test. And here we're using this random forest regression. This one line over here, this is our fancy machine learning AI algorithm, just that one line. Remember, we asked ChatGPT, what is a random forest regressor? So now that you're all experts, you know what it is. We're going to fit it to the train. We're going to see how it works on train. And now we're going to apply it to our test set. And here we're applying it to our test set. And we get an RMSE score of 1.72. Remember, RMSE is something along, when you think RMSE, think standard deviation. So this model is quite good. It says that all values lie within 1.7 on either side standard deviation. So a plus 1.7 sigma on either side of the value. With each random forest, with each model, we can look at the feature importance, see which features are important, which features can you drop to make your model more efficient. And finally, this is making the predictions for our test set. So here is our CLF model. We're now predicting it on Zindi's test. We read in the test set all the way at the top, and now we're only applying it to our test set at the bottom. We are looking at our submission file. We can scroll up to the top to make sure that it looks the same as the sample submission I showed you at the top. We've got that 16-second weekday evening rush hour, and it says that it's going at about 10 meters per second, which makes sense if we think back to that bell curve earlier. I personally would be a bit nervous about this 16 and 15 because it doesn't fit in perfectly with that bell curve, but a bell curve does have a tail, so maybe. You can see I'm really passionate about data science after starting off not knowing what to do. And finally, our last step is to take this table, this data frame, and turn it into a CSV file. A CSV file looks exactly like an Excel file. The most important thing to remember is to set your index to false. Zindi only takes in a 2-column file. It will only take in a column that's got ID and type. Apologies. And we're going to set the index to false. Once we run this cell, we can come back, look over here. We're going to refresh, see if anything's there. And here we have our baseline submission for Mozambique. When you click download, we're going to go to the competition, which, if we refresh, has just started. So I can now click submit. I can choose a file. I'm going to go to my downloads. There's my Mozambique submission. I'm going to click submit. And now I get 2.44, which is very different to this 1.72 that my model gave. That's a bit scary. But remember, this was me modeling on the train. And the train is completely different to the test, because the train is on these roads and the test is on these roads. Question to ask ChatGPT, question to ask your friends. How do you deal with a distribution and train and test being different? Back to my submissions, I can go onto the leaderboard and haha, I love doing the tutorial because it means I'm first on the leaderboard always. So please join the competition over here. Remember to set your country to Mozambique. I will be checking the discussion forum periodically throughout the day. If you need any help, please do go onto the discussion forum. So don't... So join the competition, get hacking. Please remember to use the hashtags at Zindi Africa, hashtag Yango Education, and hashtag Zindi Hack. There's no losing, only learning. So good luck.